Here, we'll examine another type of lipid called phospholipids. Like fats, phospholipids have a backbone consisting of a glycerol molecule. In a phospholipid, this H atom is replaced by a fatty acid, and this H atom is replaced by another fatty acid. Instead of being replaced by another fatty acid, this H is replaced by a group containing phosphate, or PO4. And this group often contains a nitrogen atom as well. The important thing to note is that this group has positive and negative charges. Water is attracted to positive and negative charges, and atoms that have a partial charge, such as an oxygen atom which has a double bond to a carbon atom. Let's focus on this part of the phospholipid molecule. Because this part of the molecule attracts water molecules, it is called hydrophilic, or water-loving. And because it has charges, it is said to be polar. The long chains of carbon and hydrogen atoms have no charges, and they tend to repel water. Because this region repels water, or fears water, it is said to be hydrophobic. And because it has no charges, or partially charged atoms, it is called nonpolar. This is also called the hydrophilic polar head, and these are also called the hydrophobic nonpolar fatty acid tails. Note that sometimes either one or both of the fatty acids in a phospholipid can be unsaturated, which means it has one or more double carbon-carbon bonds and less hydrogens than a saturated fatty acid. Notice the presence of a double bond alters its shape. But the fatty acid tail is still hydrophobic and nonpolar. If we take a diagram of the formula for a phospholipid and break off the fatty acid tails, we can draw a simplified diagram around it, where the green circle is the polar head and the purple protrusions represent the nonpolar tails. Remember, the polar head contains positive and negative charges, so we'll represent the polar head like this. We'll imagine a few phospholipid molecules added to water. Because of their charges, the polar heads of these molecules tend to attract each other. These charges also make the polar heads attract to water molecules. The tails, which are all nonpolar, also tend to mix with one another. These forces cause the molecules to reorient themselves, and they move together like this. Their nonpolar hydrophobic tails tend to repel water. They tend to form two layers, layer 1 on top and layer 2 on the bottom. Because it has two layers joined together, this is called a phospholipid bilayer. As you'll see later in this course, phospholipid bilayers form the main components of cell membranes.